Right, this is the second video in the data section, and it's on sampling. If you just recall back to the introduction, this section data really is about data, how you gather it, and how you use that data in order to draw conclusions. And typically, what we're doing is we're taking samples of data in order to draw a conclusion about a population. So a population is the entire group about which you want to draw conclusions, and a sample is this subgroup from which you will collect that data. So, for instance, if we wanted to very trivially find the average heights of the population of the United Kingdom, then we could sample 1,000 people and we'd take the mean of those 1,000 people, and then we would infer from that the mean of the population would be that value with some kind of error function around it. You know, it might plus or minus 2% or something like that. It depends on the size of the sample. It depends on other factors. So, but broadly speaking, that's what we're trying to do. So typically a population will have certain parameters defining it. We like to talk about parameters. The one we're most interested in most of the time is the mean. But we also talk about the spread as well. So we're coming on to standard deviation and talk about that a bit later. But that is another parameter of the data that we might wish to estimate. The point is really, if the population is sufficiently interesting, it's probably large, and we don't know those parameters, and we can't actually find them out exactly. All we can do is, or we could, but obviously the costs are very, very high. But basically, we gather data, we form estimates, and we accept those estimates as being the fact, and then make our judgments and decisions on that basis. So yes, we take these samples in order to estimate the parameters for the whole population. Now that estimate won't be exact; it will be subject to some error. So we might define that in terms of plus or minus 2%, but usually, even if we say plus or minus 2%, there's still a chance that it might fall outside the plus or minus 2%. So there are various ways of actually defining that. That we're not primarily interested in that, certainly not in this video. Now, if we want an accurate low error possible, then what we need basically is a large enough random sample of the data. Sounds easy enough, but actually making your sample random is not always that straightforward. And of course, if it's large, large samples are expensive. So really what this sort of the science of sampling is really all about is trying to make a balance between accuracy and cost. So just broadly speaking, if you reduce the size of the sample, or if you make data easier to collect, so those are kind of two prime ways that you're going to actually reduce the cost of sampling, then what you're doing is introducing a risk of not having a representative sample. That increased risk is reflected in the sort of the error, the plus or minus 2%, or however we want to define it. So so that's it. So we have a number of ways of actually of sampling, of actually breaking down the data in terms of groups and things like that. Let's have a look at some methods. Okay, so now there are basically lots, but it's we're just dealing with a few here, the ones that are likely to come up at this level. Stratified, let's just go straight into this. Stratified. So the idea of stratified is to split the population and then avoid an error resulting from a random sample that disproportionately favors one of the groups. Right, okay, so yeah, sounds good idea. But of course, this has got its own potential problems. I mean, if, for instance, we we wanted to find the average height, same example, average height of the population of the UK. Say population of adults of the UK, of which, what will there be? 45 million, something like that. So we could say, well, this is a bit unfair. If we actually take a random sample of 100 people, it might be that there might be 70 men there and 30 women in that, just through the randomness of your selection process. And that, therefore, is going to give us a disproportionately high proportion of men, on the basis that, in general, men, overall men are taller than women. Then we're going to get a distorted result. So you say, okay, well, what we'll do is we'll sample 50 men and 50 women. Okay, but then it turns out actually that the population of the UK is not 50-50 men and women. In fact, well, I can't remember which way around it is, but I think there are more men than women. The other way around. And so if you therefore do that stratification, you may be misrepresenting those proportions in the population. So I mean, here's an example which kind of helps. Assume that we need to estimate the average number of votes for each candidate in an election. This country has 3 towns. Town A has 1 million factory workers, town B has 2 million office workers, and town C has 3 million retirees. And we're kind of working on the basis that the voting preferences for these 3 different groups may be different. So if we take a random sample, we might well find, out of it, if say it was 100 people again, we might well find that the factory workers are sort of represented, kind of with too high a ratio, and it's going to distort the results of our findings. So what we're effectively doing is breaking our sample size in the ratio 1 to 2 to 3. So that would be a 6. Well, a 6 is about 16%. So that would be 16 out of 100 would be from town A, and 32% from town B, and so on. So that sort of breaks it down. It reduces the risk of misrepresenting one particular group, sure, but as mentioned up here, then obviously it introduces a different problem. Okay, so what else have we got? Opportunity and convenience. So this really, these are 2 names for the same thing, really. So more or less anybody who's willing and able to actually do it. It's not going to be random, is it? Because people who are willing to do it may, or are convenient, they just happen to be available, may well not represent our group for very well. I mean, if we, for instance, wanted to find out, do some study on how willing people were to do surveys, then by actually surveying anybody who's willing, we're definitely going to get a very distorted results. So that's something to bear in mind. But obviously it's going to be reducing the costs, isn't it? So so that's that one. I'll not read through this. You can rewind and read through that at your leisure. Systematic. Yeah, this comes up every nth person. Let's say this is often the thing we do. We'll survey every 10th person that we come across. Yeah, so it's a cost reduction mechanism. It may be successful in certain circumstances. but also it may introduce or may reduce the randomness and actually effectively build in some kind of pattern into your survey. So there's an example further down that might help to sort of illustrate this. So we got cluster. That's kind of quite imaginative. So divide into groups, then randomly select which group we're going to survey. So going back to the voting patterns and towns, we might well say there's a country with 100 towns in it. We might well say, okay, let's choose at random 5 of those towns, and then we'll go through and survey those towns. So yeah, it is sort of random, but again, you know, if you just happen to choose the town with lots of retirees in it, then you may well get a distorted result. This we can operate at 2 levels, and when we talk about cluster, we could actually, you know, within our cluster, with each of the clusters that we select, we could actually then have a stratified sample, or we could have a you know, another cluster. So you know, that would be a kind of 2-stage process, and that applies to all of these actually. And then this one, quota, yeah, and this one we can control the class, because basically we're going to just say, well, we're just going to do 100 people. But of course, we're limiting the size of the sample, and therefore, you know, we're increasing the error. So it's just another example of, yeah, we can reduce costs, but at the expense of the accuracy of our estimates. So again, you know, you can read through this at your leisure. And then there are others. Say, you see, people seem to invent these things willy-nilly, so you could probably find hundreds of different methods if you wanted. There's a table here. Again, I'm not going to read through this, except we can see the kind of ones that we're you know, we've already talked about. I mentioned multi-stage, of course, but that applies, you know, it's some combination of 2 of these things. The top one, random. Well, yeah, that's really what we want at the end of the day. It's a question of how big your random group is. Cluster, we mentioned. Judgment. Sample group members are selected on the basis of judgment of researcher. Oh, well, that sounds a bit dodgy, doesn't it? I mean, depends on the researcher's views. Quota, yes. Convenience, we've mentioned. Snowball, that's an interesting one, but anyway, we'll not worry about it. Okay, so let's just have a look at a few examples to help. A large number of spectators attend a football match at a ground in England. One of the stands contains 1,390 seats, numbered from 1 to 1,390. Describe how random numbers could be used to select a random sample of 80 of these seats. Well, you write all 1,390 numbers on pieces of paper, put them in a hat, and then take 80 out at random. So that, you know, that would be probably as random as you could get. The ground authority wishes to carry out a survey into spectators' opinions of the catering facilities at the ground. It proposes to ask the spectators occupying the 80 seats selected in previous part to complete a questionnaire. Suggest 2 practical difficulties that might be encountered in carrying out this proposal. Right, well, first of all, I might not do it if it's a questionnaire. That would be a practical difficulty. Then you wouldn't have your 80. Then what do you do then? Do you go back and select some others, and then it wouldn't be random anymore, would it? Catering facilities will vary from section to section. Yeah, well, and even if maybe there's only one catering facility, but of course, if you're in a part of the ground that is furthest away from the catering facility and you want to go along at half time and get your cup of Bovril, then you're probably going to have a long wait, because the people in the queue in front of you, those who've got seats close to it, so that sort of thing. What else? Part B, a market research company is employed to investigate the amount of interest taken in sport by the population of the United Kingdom. James, a new employee of the company, suggests that interviewers should be stationed outside each exit from the ground with instructions to interview every 100th person leaving the ground after the match. State the name given to this type of sampling. Well, this is systematic, one of the ones on the list above. Give one reason why the results of the investigation suggested by James might be biased. Well, here we go. I mean, you know, people who are less interested in sport might actually leave earlier. So you know, by the time you got to the 100th, then you've got somebody who is more interested, and then you miss the 101st, who is less interested in the 102nd, 103rd, and so on, and you get the 200th. So you know, there might be that sort of characteristic of that data. We don't know. If we don't do it randomly, you know, we're liable to suffer any of these things. Suggest two practical difficulties other than those mentioned in parts A, which might be encountered. Well, when leaving a football ground, people do tend to be in a bit of a hurry, and I think probably find that trying to get you know, stop the 100th person on the 200th, actually you might be unsuccessful. Also people coming out quickly. So the 200th person, you might be able to get the 100th, but then the 200th person will actually come out while you're still interviewing them. You know, it's possible. So so that gives you a bit of a flavor as to this sort of thing. Yeah, again, balancing cost with the randomness, basically. Let's have a look. A fan club has 2,076 members who are divided into 8 branches. The committee wishes to seek views on where to hold the next annual meeting. A sample of 100 members is to be obtained and their views sought. The following suggestions are made as to how to choose the sample. Suggestion A, right, okay, have to think about this. Members are selected from all 8 branches. The number of members from each branch is proportional to the size of the branch. Okay, so this is stratified, isn't it? The branch secretaries are asked to choose the appropriate number of members from their branches in any convenient way. So they're given the appropriate number because that's done that's decided on the size of the branches. So if one of the branches was a quarter, had a quarter of the members, then they would have a quarter of the people surveyed. So that quarter of that 100 be 25. But within those 25, the branch secretaries are going to choose whoever. They might put them in a hat, draw them out, or they might just happen to do the first 25 people that they're in touch with, or, you know, whatever. It's just up to them. Suggestion B, 2 of the branches are selected at random. 50 members from each of these branches are selected at random. Okay, so we put the 8 numbers into a hat, we choose 2. And out of those 2, with the first one, we put however number of members they've got into a hat, and we choose 50 of those, and then we do that for the other branch. Okay, so this is a kind of well, it's primarily cluster, but then it is kind of random within that. Members are selected by a random process from each branch. The number of members from each branch is proportional to the size of the branch. Again, this is stratified. And members are selected by the chair of the committee from the branch she is a member of at the next local meeting. Well, this is, yes, opportunity. So for each of these, name the method of sampling. Well, okay, for A, that's stratified, and then within that we've got opportunity. It says either state that each member is equally likely to be included, or explain why this is not the case. Well, this is not going to be the case, because the biggest branch will have the most to be selected. So basically, the number of members from each branch is proportional to the size of the branch. Okay. So the branch secretaries are asked to choose the appropriate number of members from their branches in any convenient way. So is each member equally likely to be selected? Then we'd have to say no, because the biggest branch will have most people to be selected. So if that branch is selected, then you could be one of 50 people, as opposed to a small branch where you might be one of 3. Okay. B, yes, cluster, and no. Well, if you're in a small branch, this is the same thing. You are more likely to be selected if you're in a small branch. C, stratified. Yes, but this is most likely to result in the next AGM at the largest branch. So yeah, every person is equally likely in this scheme to be selected, but you know, we're going to have most people from the largest branch, and assuming that people are just going to go, well, it's more convenient if we have the meeting at our branch, because then I don't have to travel, then that's probably where you're going to end up having it. And finally, opportunity. Well, no, because unless the chair of the committee is kind of equally in touch with, equally involved with all the members, then, you know, it won't be. There'll be some bias in there. Okay, part B, state giving a reason which of the 4 methods is preferable from a statistical point of view. I think this is quite arguable, actually. The answer they're looking for is stratified, but I think it's a little bit more complicated than that, because you know, it's quite possible that, you know, the cluster method will give us a better result and with least error. So give a reason why suggestion A might be preferred to suggestion C. It may be cheaper to sample people on an opportunity basis. As far as I can see, that's the method. A lot of these things are subjective, if I'm honest, and you know, I think the questions on these are actually can be quite difficult for that reason. You know, what you have to do is you have to kind of understand the methods, understand the trade-off between randomness, large random samples, in other words, and you know, and the cost, and sort of draw your own conclusions. So quite difficult to give you a really watertight method of doing these, but if you understand the underlying principles, then that will stand you in good stead. Let's just have a look at a couple more. Emil wants to investigate the proportion of the population who watch soap operas on television. One day he asks each of the students in his drama class, did you watch a soap opera on television last night? This is the proportion of the population. We're assuming this is the population of the United Kingdom. Sorry if you're watching this video from another country, but that's where I am at the moment. So yeah, sampling one drama class for the whole population, it doesn't sound terribly good, does it? So this is opportunity sampling. These are the people who are just available. It's also essentially a quota system, so we kind of got 2 in there at the same time. Comment on the use of the proportion of students who watched a soap opera last night obtained from the sample, whether this is representative of the proportion of the population who watch soap operas on television? Well, no, not at all, is it really? And of course, apart from, you know, the error, because the sampling is very small, then we're talking about people of a certain age group, but they're interested in drama, aren't they? This is a drama class, so you're going to expect these people to be more interested in drama on TV, and so it will be biased. So, and then finally, let's have a look at this one. Charlie is studying the time it takes members of his company to travel to the office. He stands by the door of the office from 8:40 to 8:50 one morning and asks workers as they arrive how long their journey was. Well, this definitely seems to be flawed, doesn't it? You know, if you travel further, there's more chance of delays and so on. So, state the sampling method Charlie used. Well, opportunity. State and briefly describe an alternative method of non-random sampling Charlie could have used to obtain a sample of 40 workers. Well, non-random is again is a little bit of a moot point. I mean, if we do, it's a question of how random we do it. I mean, it's kind of got zero randomness if we just pick out people that, you know, and say, right, we're going to take your time, and we're going to take your travel time, and we're going to take your travel time. But if we do it on, say, a systematic basis, you know, every 10th person based on something, alphabetical order perhaps, or something like that, then you know, it's not completely random, but it has some element of randomness in it. So I think to talk about random and non-random, actually a little bit of a mistake of the question. So yeah, so we could use systematic. Every nth person is, and we calculate that in order to give us 40 in total. Taruni decided to ask every member of the company the time, X minutes, it takes them to travel to the office. State the data selection process Taruni used. Well, we're basically sampling them all, aren't we? We're actually looking at the entire population. In all the categories I gave you above, it all presupposes that we're taking some subgroup of the population. So you would say really is, you could only describe it as systematic. It's basically every one-th, every second, every 10th, every one. So systematic, I think we would say. Okay, so hopefully that's given you a flavour for sampling. As I said, it is quite a sort of subjective kind of area. Understand the methods, understand the trade-offs between low error and cost, and then you have to kind of make some judgment. A bit of practice needed, but hopefully it's you know, it's not difficult conceptually, but actually to get the same answer that the examiner is expecting is not necessarily that easy. Okay, so that's it. Hope it's been useful, and I will see you in the next video.